guys, hope you're doing good. So here is our Unit 7 test, and the first thing it's asking for is to find a midpoint. So what I like to do is just draw a diagram, and I go ahead and I put CH, and then right here in the middle is my midpoint. Okay, so then I'm going to label my coordinates. I have a -5, -2, and a 9, -4. All right, well, I'm finding my midpoint, so all I have to do is just plug it into the formula. So I'm going to take my two x values. I'm going to find their midpoint first, which is going to be -5 plus 9 over 2, which -5 plus 9 is 4, divided by 2 gives me 2. So I know the x value of my midpoint is 2, and now I'm going to find my y value. So I'm going to take my two y values, -2 and -4. I'll add them together and divide by 2. So -6 divided by 2 gives me -3. That means my midpoint value is a +2, -3. All right. Given that m is the midpoint, so that means they're giving us the midpoint this time, I need to find my coordinates of one of my endpoints. So my midpoint is going to be 5, 3, and let's just say this is x and this is y. Y is going to be -9, -1. So my whole goal is to find this coordinate right here, x and y. So first things first, I'm going to find my x just like before. All right, so this time I don't know my x value. I'm going to do x plus this -9. Again, I'm putting an x here because I don't know that x value. I'll divide it by 2 and set it equal to the x value of my midpoint, which is 5. I'm going to multiply both sides by 2, and I'm going to have x plus -9 equals 10. All right, and then I'm going to add 9 to get x by itself, and add 9 and get x equals 19. So 19 here, and now I just need to find my y value. So the same idea, I'm going to take y and add it to the y value of my other endpoint, -1, divide by 2, and set it equal to the y value of my midpoint, which is 3. So I'll multiply both sides by 2, multiply both sides by 2, and I end up with y plus -1 equals 6. I'm going to add 1 and add 1, and I'm going to end up with y equals 7. So my midpoint is equal to 19, +7. Okay, so find the distance between the 2 points. I'm just going to view this as a 2. All right, that's the way I solved it. So what I'm going to do is I'm going to just label them x1, y1, x2, y2. And I'm going to plug it into the distance formula. So I'm going to do y2, which is -3, minus y1, which is 4. Oops, I have a few parentheses here. I will square it. And then I'll add it to -8 minus 2, and I'll square that. So -3 minus 4 is -7. I'm going to have to square that. And then -8 minus 2 is -10, and I'll square that. I'll end up with 49 plus 100, which will give me 149. I will take the square root, and I will get 12.2 something. It says to round to the nearest hundredth. I don't remember what that was. Maybe 4 or 3. Okay, so this is a square. All right, that means our two diagonals are congruent. Where they cross, they're right angles. It's also an isosceles triangle up here, a right isosceles triangle. and it wants us to find the measure of ABD. Well, because this is a right angle, and we know these two legs are congruent, that means these two angles have to be congruent. And their only measure would be 45 degrees. Okay? Or you can think that the diagonals bisect opposite angles, which if this is 90 degrees, 90 divided by 2 is 45 also. All right, so if the measure of angle BEC is 3x plus 9, solve for x. So BEC is this angle right here, which is going to be a 90-degree angle, BEC. So I'm going to go ahead and do 3x plus 9 equals 90. And I'm going to have 3x equals 81. I got that by subtracting 9 from both sides. And x equals 27. And that's it. That's all we had to solve for. All right, so if the perimeter of this figure, ABCD, is 56, and CD, this side right here, is 2x plus 4, solve for x. So what I'm going to do is I'm going to take the perimeter, 56, I'm going to divide it by 4 because there's 4 equal sides since it's a square. And that's going to give me 14. So then I know that one side is equal to 2x plus 4, and that actual side measure is 14. I'm going to set the two equal. So I'm going to subtract 4 and get 2x equals 10, and divide by 2 and divide by 2, and get x equals 5. Okay, next up is a rhombus. So JN, right here, oops, it'd help if you could see that, is equal to 11, and JL, the entire piece, is equal to 4x minus 2. All right, well, if you remember, the diagonals bisect each other. So what I'm going to do is I'm going to do 2 times 11, so this whole piece, and it's going to give me 22, which represents the whole piece. So now I'm going to do 4x minus 2 equals 22, and go ahead and solve. I'll add 2 to both sides, 4x equals 24, and then I'll divide by 4 and divide by 4 and get x equals 6. Right, again, this is because I know my properties of a parallelogram. A parallelogram. All right, so MN, which is right here, this piece, is equal to 2x plus 3, and NK, which is this piece, is equal to 5x minus 9. Well, since that's a diagonal, remember that these are never fails. Anytime I go to make a video, I always sneeze. Okay, so the diagonals are bisected, which means they're equal to each other. So 2x plus 3 equals 5x minus 9. I'm going to subtract 2x and subtract 2x and get 3 equals 3x minus 9. I'll add 9 and add 9 and get 12 equals 3x. And then I'll just go ahead and divide by 3, and get x equals 4. But it says to solve for MK. So then I look at MK, and I'm just going to plug it in. I can plug it into either of these. This one looks a little bit friendlier. So I'm going to do 2x, not x, 2 times 4 plus 3, which is going to be 8, plus 3, which equals 11. And then it's MK, it's the entire length. So I'm going to do 11 times 2 and get 22. So my length for MK is going to be 22. Okay, so moving along now to, let me zoom out a little so that maybe you can see the image. Okay, also. So it says that JM, which is this side, is equal to 4x 9x minus 7, and KL, the opposite side, is equal to 6x minus 11. So remember, opposite sides are congruent. So because of that, I am going to set them equal to each other and go ahead and solve. And I'm going to get 2x equals 4, right, when I add 11 and add 11, and divide by 2 and divide by 2, and get x equals 2. Okay, so next up it says that if JML, this whole angle right here, is 84, so this angle right here I know is 84, then find MJK, this angle up here. Well, because this is a parallelogram, their opposite sides are parallel, which makes these same side interior angles, and they sum to 180. So I'm going to do 180 and subtract 84, and I will get 96. And the measure of angle MJK will be equal to 96. All right, next up, if the measure of JLM, so JLM, this little angle right there, is equal to 29, and JNM, right, am I reading that right? JNM is equal to 80. Then solve for MJK. MJK, the whole angle. So, what I see is that this is 29, which means this is 29 because they're alternate interior angles. And I also know that this is 100. So then if I'm solving for JKN, this angle right here, then I can see that this, hopefully you guys can see this right here, is a triangle. So I'm going to do 180 minus that 100, right? I got 100 because this is 80, then that's a linear pair. And subtract 29, and I end up, oops, sorry, hard to see, with 51. Okay. So, here is a rectangle, and if PR, which is the diagonal, is equal to 9x minus 4, and QS, which is also a diagonal, is equal to 3x plus 8m, well, the diagonals of a rectangle, well, anything with 490-degree angles is equal. So to solve, I'm just going to set them equal. 9x minus 4 equals 3x plus 8. 8. Just get rid of the m there. Sorry, little typo. So, I'm going to have 6x minus 4 equals 8. And then I'll add 4 and add 4. And I will get 6x equals 12. Divide by 6, divide by 6, and get x equals 2. Well, it wants me to solve for TQ, which is going to be half. So I'm going to choose either of these diagonals and plug it in. So I'm going to do 3 times 2 plus 8, 6 plus 8, which is going to give me 14. And then I'm going to need to divide it in half to get TQ, right? Because the diagonals are bisected. So 7 would be my answer. All right, next up is the measure of QPT. So QPT, that angle is 36 degrees. It says find the measure of TQR. TQR. This is the angle measure we want to find. Well, I know that all the angles are bisected. So if this is 36, then this would be 36, and they have to add to 90, right? So I would do 90 minus 36 and get 54 degrees. right, so here's PR. All right, and SR, so I have this triangle right here, PR, and here's S, and PR is equal to 14, and SR is equal to 7. It wants me to find QR. Well, oh, you can't see. So I've gone ahead and redrawn this triangle right here. If I find PS, this side, then I'll find QR because the opposite sides are congruent. So I'm just going to use the Pythagorean theorem. I'm going to do x squared plus 7 squared equals 14 squared. X squared plus 49 equals 196. X squared equals 147. Take the square root, and x is equal to 7 rad 3, which x is my PS, which is opposite QR, and that is equal to 7 rad 3. Boom. Moving right along. Okay, so now we have a rhombus. All right, well, all sides are congruent, and we're going to see here the measure of BAC. So BAC, this angle right here, is 3x minus 1. And the measure of ABC, oops, let me go to the right page, is ABC, this whole angle right here, is equal to 80. Well, notice that these are both congruent, those sides, so that makes this an isosceles triangle. So this angle is technically 3x minus 1. And they form a triangle right here. So we're going to do 2 times 3x minus 1 plus 80 and set it equal to 180. We multiply this by 2 because there's 2 of the identical angles. We add 80 because that's this angle measure. And we set it equal to 180 because we know that the 3 angles of a triangle sum to 180. So I'm going to have 6x minus 2 plus 80 equals 180. I'm going to combine some like terms and get 6x plus 78 equals 180. And move things around and get 6x equals 102. I'll divide by 6 and get x equals 17. Okay, so find the perimeter of a rhomb, which let's just say this is not rhomb, but A, B, C, D with E in the middle. If AE equals 5, so here is AE, and DC, this piece right here, equals 13. So AE is 5, which means this piece is 5, and DC is 13. Okay, well remember that the diagonals are perpendicular to each other, so there's a right angle. So I have this triangle that is 5 and 13, and I need to solve for the, oh, whoops, I'm making this way more complicated than it is. Okay, the perimeter. If each side is 13, I'm going to do 4 times 13, and I'm going to get 52. So my perimeter is 52. All 4 sides added together. Okay, big thing that this is an isosceles trapezoid. That means both sets of base angles are congruent, and both of these legs are congruent. So, if AB equals 9 and CD equals 25, we need to find the midsegment. Well, remember to find that, we just do base 1 plus base 2 and divide it by 2. So 9 plus 25, that will give you 34. Divide it by 2 and you get EF equals 17. Okay, next up again we have AB and we have CD, but this time they're given to us as expressions. And they actually give us EF, so they want us to solve for x. We're still going to do the same thing, base 1, which is 2x plus 3. We're going to add it to our other base, 6x minus 9. We're still going to divide it by 2, but we're going to set it equal to 13. All right, well, I've got to get rid of the 2 by multiplying both sides by 2. And I'm going to have 2x plus 13 plus 6x minus 9 equals 26 this time, because 13 times 2 is 26. I'm going to combine some like terms and end up with 8x minus 6 equals 26. I'll add 6 to both sides and end up with 8x equals 32. Divide by 8, divide by 8, and get x equals 4. Okay, so if the measure of angle A is 118, find the measure of angle C. Remember that A and B are congruent, so this would be 118 also, and that these two are between parallel lines, so they're same side or consecutive interiors, so they sum to 180, which means we're going to do 180 minus 118 and get 62 degrees. Oops, if you could see that. Okay, so now it gives us two base angles, right? D and C, and we know that they're equal to each other. So we're going to set them equal to solve for x and then eventually get angle B. Okay, so 18x plus 8 equals 11x plus 15. All right, I'm going to end up with 7x equals 7 and x equals 1. I'm going to just go ahead and solve for angle C first. So I'm going to do 11 times 1 plus 15. And I'll get 26. And then to solve for B, I'll do 180. Oops, gosh, you can't see any of my work. I'm so sorry. And I'll subtract that 26. And I will get 154 degrees. Okay, for the last question, rather than spend a bazillion hours going over it. Okay, so I have PQ, I have QR, I have SR, and I have PS. What I did for this one is I went ahead and I found the distance between P and Q. All right, and I got 25. All right, and then for the next one, QR, I found the distance and I got 5 rad 2. Okay, those don't match, so I instantly know that it's a square. I mean, not a square. Could be a rectangle, could be a parallelogram, could be neither. All right, so then I go ahead and I find the slope. And I see that this is 3 over 4 and this is negative 7 over 1. Okay, so now I know that I don't have opposite reciprocal slopes or even the same slopes. Okay, but now I'm going to find the distance from S to R, which I get 5, which matches PQ. So now I know this is 5 and this is 5. And I go ahead and I find the distance from P to S, which I see also is 5 rad 2 and 5 rad 2. And I compare their slopes, and I see that these slopes are identical, so they're parallel, and these slopes are identical, so they're parallel, which makes this a parallelogram. All right, and then down here, I go ahead and I find the distances of all four sides, which means that they're all congruent, even though my drawing doesn't quite look that way. Well, if I know that all of their sides are congruent, and then I go ahead and I solve for their diagonals. If they're congruent, then I know that it's a square. But what ends up happening is when I solve for AC, I get rad 50. Let's see what happens when I solve for dB. Okay, so I've taken the coordinates and I've done -2, which I got from B, -2, minus -11, which that's going to become a plus. All right, and that is going to give me 9, which I'm going to square. And then I did 10 minus 1, which is going to give me 9, and I'm going to square that. All right, well, I'm going to add those two together, 81 and 81, and I'm going to get the square root of 162. When I plug that into my calculator, I end up with 9 rad 2, which is not the same as 50 rad 2, which technically would be 5 rad 2. So it would be a rhombus. All four sides are congruent, but the diagonals are not congruent. So a rhombus, which it's hard to read my writing here. Rhombus. And that's it. Good luck, guys. Let me know if you have any questions.